Hello, class. Today will be our first lecture in a long series of lectures on the origins of paper. Nah, I'm just kidding. Okay, so in our OneNote notebooks, under your guys' name, we should have a new section. It's titled Unit 2. So we need to go in and access our Lesson 2.1 notes. That are the ones I'm looking at right now. So once you do that, make sure you go in. So let's start problem number 1. Another classic notice and wonder. So I want you guys to pause right now. I want you to be on your own lesson 2.1 notes, and I want you to write down at least 2 things that you notice and 1 thing that you wonder. So go for that right now. Okay, should be back from our pause. So there's a couple things that I want to draw your guys' attention to, okay? And whatever you wonder, that's entirely up to you. But here are some things that I need us to try to make sure that we notice here. Okay, so notice that rectangle A has regular letters. And what I mean by that is that there are no apostrophe markings that we call, right, the prime. So there's no P prime, S prime, R prime. It's just P, Q, R, and S. And this should indicate to us, so rectangle A has regular letters, and it is the only blue rectangle. So there's a couple things that this should point out to us. Is this should tell us that A is the original. Not only because it's the only one that's a different color, but because it's using regular letters. That's just something that now we can kind of fold into our understanding of things. Okay, so then rectangle B has been flipped sideways, and it is a reflection. And here's how you can notice if you didn't quite pick up on this. Because look, if I draw a line halfway in between, and then P will get flipped over this line and become P prime, Q will get flipped over and become Q prime, S will get flipped over and become S prime, and R will become R prime. So as you can see, it's kind of folded sideways, flipped sideways over that line of reflection. So we notice that P was on the top left, now it's on the top right. Q was on the top right, gets flipped over to the top left. Okay, and the other thing I want us to notice is that rectangle D has been rotated 180 degrees. So we should be noticing a rotation. And here's how. From the original, P was up here in the top left. And look where it is, P prime is down here, which means the rectangle got turned 90 degrees and then another 90 to make a full 180, right? The rectangle got flipped on its head. So now what was up here with P is now down in the corner as P prime. Same idea with I don't know, let's pick S, right? S started down here from the original, and then it was flipped 90 degrees up and 180 degrees over, and now it's been flipped on its head. So it's been rotated. Sorry, I don't want to use the word flip. It's been rotated 180 degrees. So, right, we know about rigid transformations, so those are things that we're going to be building on. C kind of doesn't really follow any pattern, but you may have noticed that C kind of mixes up the order of the lettering. Okay, so those are some important things to notice. Now, let's talk about problem 2 here. It says triangle ABC, which is here on the left, is congruent to triangle DEF, which is here on the right. And this is called a congruence statement. We're going to start seeing these more and more. This is called a congruence statement. What it's saying is very simple. Hopefully we've seen this before, right? A little triangle represents the word triangle. We just use symbols instead. ABC is the same. Same thing. Little triangle, DEF is the same. And this is our congruent symbol. Equal sign with the kind of swoopy thing on top, the squiggle on top. That's our congruent sign. So this is the sign for congruent, right? In math, we create symbols so that everybody can see them and we don't have to translate into any one language. We can use a universal language. Okay, so all this is a congruence statement. It says triangle ABC is congruent to triangle DEF. So number one's asking us to find some rigid motions that takes triangle ABC to DEF. Now there's a few ways we can do this, but I want to focus on the easiest one. I hope what you guys notice is that it looks like the triangle has literally just been folded and flipped over. And sure enough, if we draw a line, if this is our mirror line, if this is our line of reflection, then the triangle just looks like it's getting flipped over onto the other side, which it is. So we can say that for number one, a sequence of motions that take the triangle is, we can say for number one is triangle ABC is reflected over a line that is halfway in between the two triangles, right? So I mean, essentially we just, wherever this is halfway in between, so that we have the same distance here to here and the same distance here to here. So that's it. So a reflection should take care of it in one trip. Okay, now question 2 is asking us, what is the image of segment BC? That's a great question. Remember, image is always the result. So we're thinking of, this is the original, and this is our image. So if you guys look and it says, what image of segment BC? What's the image? Well, BC is the kind of the one that starts close to the mirror line and slants out away from it. So the same idea is, we want to look for where's the point that's close to the mirror line and starts going and slanting away. And sure enough, that's segment EF. So segment EF is the image of BC, meaning that it is the part that resembles the original. It's just flipped onto the other side. 3 says, explain how you know these segments are congruent. Well, how we know is because we used a rigid transformation. We did a reflection to get from one triangle to another. So all the parts in the same position are congruent, right? That's all we're saying is, when things get flipped over in a reflection, then all the parts that are kind of, resemble each other, since we didn't change the shape or size because we did a rigid transformation, then they're congruent. And then lastly, 4 is saying, justify that angle ABC is congruent to DEF. Well, first of all, let's make sure we know, where is angle ABC? Starts at A, goes to B, pivots up to C. Right here is angle ABC. And then angle DEF starts at D, goes to E, pivots to F. This is angle DEF. So once again, justify that they're congruent. Both of these angles are the ones closest to the reflection line, so they are congruent because they're the ones that kind of match up with each other. Okay, so again, we can see a reflection, we see a congruent statement that's given, and then we can kind of figure out what parts kind of match up with each other. And that's really what we're going to build on right now. So problem 3 is, we're going to construct something. So if you want to make a construction, you can follow along with my construction if you want to, which I encourage you guys to. And I'll say this, you can pause as needed. Okay, so here I go. We're going to go to our geometry. So we're going to draw a triangle, find the midpoint, rotate it, and then we're going to take a screenshot of that. Okay, so let's see. All right, so we're construct a triangle. Keep it simple. Triangle. Boom. Perfect. Constructed a triangle. Now it says we're going to use the midpoint of the longest side. So I think AC looks like the longest side here. So I'm going to go down. There's actually a tool that helps us find the midpoint. And I just got to find it again. Yes, right there. Okay, so under construct, it's the one with the 3 dots, and it says midpoint or center. And then it says to select the segment, or in this case, I'm going to select the 2 points, A to C, and it should give me the midpoint. Perfect. And then it said we want to rotate this triangle 180 degrees around that midpoint D. So we know that the rotate is down here under the transformations, and it looks like the snow cone with the 2 dots. So we're going to click the triangle, select this point to rotate, and we're going to go 180 degrees. Doesn't matter clockwise or counterclockwise. Okay, so now you can see what we've created. If you need to go redo those, just rewind the video and you can do that. Okay, actually, you know what? One thing before I do that is I'm going to click on this thing where it says edit, and there's the A and the A, and I'm just going to hide this label because it's kind of in the way. Okay, so now we're going to take a screenshot. Oh, that's so frustrating. I just missed the B. Okay, this is better. So like I said, if you just want to follow along with me here, that's fine, but you should try doing the construction. All right, we're going to make this big so we can see everything we need to see. Okay, so we made everything. We did step 1, 2, 3. Check, check, check. It says label the corresponding parts and mark what must be congruent. Okay, so there's a couple things that we need to make sure we know. We know this word corresponding, guys. It means the ones that match up. It's like corresponding angles, right? They're 2 angles that are in the same position, but at different intersections. When it comes to triangles, corresponding parts are the parts that match up in different triangles. So think of corresponding as the things that match up. They go together, they match up, they correspond. And the other thing we're going to do here, which we need to make sure we're comfortable with, is we're going to be making tick marks, right? Those are just those little dashes, and they indicate things that are equal. And then we're going to use arc marks for angles, and they show a certain angle. Okay, so remember, tick marks are the ones that just look like this, and arc marks will mark an angle, and then we will use a tick mark on top of that. And guys, it's so that we can show a picture of all the stuff that's corresponding. Okay, so here we go. Let's start somewhere down here. Here, I'll use a different color. And all we want to do is mark the corresponding parts that are congruent. Okay, ready? So you always start with your first tick mark, you just do 1. So I'm gonna pick this side over here. And I'm gonna give it 1 tick mark. And the question is, so this is triangle 1, and this is triangle 2. So if I marked this triangle with a single tick mark, the question is, which side matches up? Well, it's not the diagonal side, and it's not the side that goes on top. Remember, guys, this triangle got rotated 180 degrees, so it got spun around, so this side over here matches up. So we give it a single tick mark and a single tick mark because they indicate that those are equal or congruent. Okay, now let's do a double tick mark. I'm going to do double tick mark, keep them close together so we know they indicate that they're a tick mark. And then that's in triangle 1. So what side in triangle 2 matches up? Well, it's the one up top. So we give that 2 tick marks. Now the last side, look, it's the diagonal one down the middle. So we're going to give it 3 tick marks. But guess what? The 2 triangles share that side. So it's just kind of marked on its own there. So that's it. If the 2 triangles share the side, then it's just marked on its own. Okay, now we're going to go to angles. So we'll stick with green. Okay, so now we want to think about down here. Let's say I want to mark this angle with a single tick mark. And the question is, which angle in the triangle 2 matches up? Well, we know if we've spun it around 180 degrees, that means the angles should be directly across from each other. So this angle here should get an arc mark with a single tick mark, right? And we just use single, double, and triple to just denote differently. 1s match up with 1s, 2s match up with 2s, 3s match up with 3s. Okay, so then in triangle 1, let's go to this skinny angle down here, and we'll give this a double tick mark. I know sometimes it gets a little messy, but double tick mark. And the question is, look at that very skinny angle. So another angle's got to match up. Well, it's got to be this one up here, guys. This really small acute angle. So give that a double tick mark. And then naturally, the only angle that's left in triangle 1, we'll give it a triple. And it's a little bit of a wider angle. But again, think, if you spin that around 180 degrees, it's going to match up with this one down here. 1, 2, 3. So now we look at this diagram, guys, and we say, oh, well, this side over here matches up with this side over there. And I know that because they both have single tick marks, right? Single tick mark, single tick mark. And the same thing applies for double tick marks, triple tick marks, and your angle markers. So all we're trying to do is just, we need to be able to see, oh, you know what? This angle matches up with this one because we spun it around 180 degrees and they look the same. Or this side matches up with this side because they're in the same position. They're corresponding. Okay, so now we need to think here in part 5, what it's asking us is just a question about what we've done here. So number 5 says, or let's do 5A. It says, what type of quadrilateral have you formed? Okay, well, what we should notice is that, right, quadrilateral, so it's got 4 sides. It's definitely not a rectangle, okay, because now you may have created a rectangle, but it's not a rectangle. It's a little slanted. So hopefully we recognize this as a parallelogram. And the definition of a parallelogram is that it has both sets of opposite sides are parallel and equal. And sure enough, look, we put the single tick mark, that's equal. We put the double tick mark, those are equal. And they're also parallel. And it says, why must the quadrilateral you have fit the definition? Honestly, we don't really need to write anything about that. But it's because all we did was make a rotation of a triangle on top of each other, and we just basically stacked 2 on top. Okay, so here's what we have here, right? Image matches up with part of the original. We call it corresponding. Okay, so here's what we're going to do is we're going to try this stuff out. We got to try this stuff out for ourselves. So right now I have another thing in your Unit 2 section. It says Lesson 2.1 classwork. That's what you guys are going to start right now. As you go along, I also distributed to you the answer key. It's called Lesson 2.1 CW key. So I want you guys to be working on your own, and then I want you to check with the answer key. That's the point. So hold yourselves accountable, right? You need to, like, you want to do this stuff right, but you also want to make sure that you can do it on your own before you check the answers. Okay? So let me just show you that real quick. So in OneNote, it should say Lesson 2.1 classwork. And look, you got all these congruent triangles, and each problem has 1, 2, 3 things that you are asked to do. Maybe you're asked to put a tick mark. Like here in number 1, maybe you're asked to state which side is congruent in the other triangle. And then maybe you're asked to place a couple arc marks to denote corresponding parts. So there's 8 of these here. And there's 3 little parts for each. So I want you guys working on this right now, getting ourselves comfortable with identifying corresponding parts. And then the 2.1 CW key is right there for you guys. Okay? So after you finish the classwork, last thing is homework lesson 2.1 homework will post. It's assigned in teams. It will show up in your OneNote. This is due Tuesday. Do your best with everything today, guys. I miss seeing you, but we will talk again on Tuesday, and we'll keep going forward with Unit 2.